Look at the graph carefully and determine the phase difference.
What is phase difference?
Phase difference is like the difference in time, and you convert it into degree. Let me find an illustrator on a GeoGebra. Phase difference. It is like this example. Okay, you leave your house like at 7 a.m. to go to school or somewhere. Okay, and then it takes you 1 hour to get to the school. This is just example. Okay.
Yeah.
You leave the house at 7 a.m. and it takes 1 hour to go to the school. Your brother leaves the house at 7:30, meaning 30 minutes later, half an hour later, after you, okay? And he will go to the same school, meaning it takes him about the same time, 1 hour. But he left the house half an hour after you. So that is the difference in phase between him and you in time, different in time, okay? And phase is a concept to describe the wave. So from the difference in time, like this, when the two waves are exactly at the same, they are coincide, okay? Yeah. Meaning that they are emitted at the same time, okay? Or you see the two waves here having the same period, okay? So if one wave, the blue wave, is emitted from the source, exactly one period or two period or three period after the first wave, it will have the same phase with the first wave. The peak and troughs are coincident, okay? But if the second wave is emitted like this, okay? Wait, let me change its state. Like this, meaning when the first wave red is at the top, the second wave is at the bottom, okay? They are said, the two waves are said to be different in phase by 180 degree, opposite in phase, okay?
Okay.
So the difference in phase here is determined in degrees, 180 degree, like opposite. Like you turn 180 degree from in front of you to behind you, okay? So this phase difference is 180 degree with in accordance with the time difference to be half period, because when the time difference is 1 period, the two waves will be coincident. Phase difference will be 0, okay? When the phase difference is 180 degree, the time difference will be half period, okay? I'll send you the link to this simulation. When so answering this problem, it starts from maximum. I change it to maximum here, the first way, okay? The second way start from 0. Second way here start from 0 and go up there. Not exactly. So you see the phase difference is 96, but I wanted to do it more accurately. See the difference between the two peaks here, from this peak to this peak, okay, is 1.4 seconds. Okay. The period of the two waves, you can start from this first wave to the next peak. The next peak is here, right?
Yeah.
Yeah. Or you can start from this 0 to the first wave here, 0 to this here. So that is 5 milliseconds. And the difference in time between these two peaks is 1.3. Sorry, 1.3, not 1.4. You see, it is a little bit in between here, not this place.
Only 1.2.
1.3, right in between two lines. You see.
Okay.
This line here is 1.2, right?
Mm.
And the next line here is 1.4. So this is 1.3 actually. You will have the difference in time of the two waves is different in time. Let's say delta t, okay, is 1.3 millisecond. And if you divide, you take the ratio with the period, which is 5 millisecond, you have this ratio, which is 13 divided by 50, 0.26. That ratio. When the difference in time is 1 period, if the difference in time delta t is 1 period, the two waves are said to be in phase, meaning the difference in phase will be 360 degrees. Okay, but this ratio is 0.26, so you would take that 0.26 multiply with 360 degrees. When the difference in time is 1 period, the phase difference is 360 degrees. Okay, so this difference in time, 0.26 multiplied with 360 degrees, you will have 93.6 degree, up to 94 degrees. Check, yeah. So we do not have exactly 94, but we have the answer 90 degrees here. Okay. So using this calculation, you can determine the phase difference to be approximately 90 degrees. Okay.
I did like the, for the maximum, the amplitude for the second wave, and then I got B for this question.
Resultant displacement at 2 meters per second. At 2 meters per second. The first wave here, okay, having 1 millimeter for displacement. The second wave having negative 1.6, right? Probably 1.5 millimeter. So the difference in displacement is 1 plus 1.6, that is 2.6. See?
Yeah.
At 2 seconds. So you just need to take their displacement and subtract one from another.